So in this video, we will learn how to find the inverse of a 3 by 3 matrix, and we have an example of A matrix which is equal to this over here, and we need to find the inverse. So what we need to first do is write the augmented format, which is basically the matrix A along with the identity. So this is a 3 by 3 matrix, that's why we are writing it along the 3 by 3 identity, and let's do that now. So that's it. The identity matrix is all ones in the diagonal, and now we need to start what is called the RREF. So what we are going to do is we are going to find the RREF of the left hand side, and whatever is left after the operation on the right hand side, this part will be the inverse. And for that you need to know what is RREF, the row Euler, reduced row Euler form. So I'm gonna need more space here, so I'm gonna remove this over here and bring this up. So I'll just give you a brief of what RREF is. I have made a video on it, so you can check that out before seeing this, but I'll explain it briefly. So what we need to do is so in each row we can only have one non-zero number, and there cannot be any digits below that number and above it. That's basically what it is, and each next pivot has to be down and to the right. So once we start this example, it will be more clear. So here we have the first non-zero number in our first row, and we need to get rid of the numbers below it, which is 2 and 3 here. So what operations can we do using the first row to get rid of row 2 and row 3? It will be minus 2r1, which is row 1, plus r2, and minus 3r1 plus r3, since we need to get rid of the numbers below the number 1 here. And one more thing I forgot to mention is that the pivot has to be 1. It cannot be 4 or anything like that. It has to be 1, the value I mean itself. So now let's just do normal addition and subtraction. It will be, the first row will stay the same, 1 1 2. Let me actually write it bigger. The second row will be, and yes, the identity, I forgot about that, 0 0. It didn't change anything here. So now minus r1 minus 2 r1 plus r2 will be 2 minus 2, because 2 minus 1 times 2 is 2, 0, and then 4 minus 2, because we are multiplying minus 2 with 1 here first, and then we are adding it to r2. So yeah, so here we will have 2, and over here we will do 3 minus 4, so it will be minus 7. And moving on, so here in row 3 we are doing minus 3r1. So for the first one it will be 3 minus 3, for the second it will be 6 minus 3, so 3 will be there, and then minus 5 minus 6, so we will have minus 11. And for these numbers, let's do the same. So it will be here minus 2 r1 plus r1 plus r2, so 0 minus 2, so minus 2, and here we have just 1, yeah, since it's a 0 over here, this number, and then 0 in the last one also stays the same. And over here we will do the same thing, so minus 3, since it's going to be minus 3 r1 plus r3, and the others will stay the same. Now what is, okay, so we are done with the first pivot here. Now moving on to the next pivot, it has to be down and to the right. So next it has to be the next row, it cannot be the same row of course, and it has to be 1 here. But we have a 2 in this pivot, so how can we change this to 1 first of all, so to make it more easier for us to get rid of all these numbers above it and below it? So what we can do here is we can do the following operation of minus r3 plus r2, So it will give you -1 here, and then we can change that sign by just doing a multiplying it by -1. So here I'm going to speed up the process and quickly write the operations. -1, 4, because this is just adding it and subtracting it, so it's not a big deal. So now next thing is to get this -1 into 1. So what we can do here is multiply row 2 by -1. So now we will have the same thing again, except that the signs will be flipped. Oops. So here we'll have 1 minus 4 -1 -1 and +1 here. Now we can use row 2 to get rid of this one over here and this 3 over here, and we can do that by the following operations of minus R2 plus a 1, R1, to get rid of this one over here, and to get rid of this 3 we can do minus 3R2 plus R3. And let me just scroll down now since I don't have enough space. So again, I'm not going to go into much detail. So here will be 106 and 2 1 -1, and here 0 0 1. So this is a perfect pivot, by the way. And we have 0 3 and -2. So now we can notice that we have all 3 of the pivots and we have all of them as ones. Now all we need to do is get rid of these numbers above the last pivot, and that is quite simple. We can do the following operations, which are -6 R3 plus R1, and then 4 R3 plus R2, and the answer would be 1 0 0 0 1 0 0 0 1, and this is always the RREF of a 3 by 3 matrix, by the way, the line. And here we have the inverse matrix, which is going to be 2 minus 17 11 minus 1 11 minus 7 0 3 and -2. MCQ question, or if you want to. So here is the A inverse matrix, which is this one. And now, as always, I do have a shortcut method for you guys. So all you have to do is you should have the matrix option in your menu on your calculator, and you would just need to input the A matrix and you would automatically get the final answer as this. So I will be making a short video on that to show you guys, of course, and stay tuned for that, and thanks for watching. If you have any questions, you can always ask them in the comment section. I'll be more than happy to answer them, and see you guys.